Hello everyone, my name is David Murakshi and I'm a Senior Product Marketing Manager with Altium. In this video, I'd like to give a quick tour of Altium Designer 19 to share with you some of its new functionalities and capabilities. So I'll be going over the new Advanced Layer Stack Manager, the new part and component search panels, routing improvement, draftsman improvement, some multi-board improvement, and the new support of printed electronics. One area that went through a major change is the Layer Stack Manager. Some of the general improvements, as you can see, is that we moved away from the dialog box. Now your layer stack is a tab next to other project documents. And with this new tabular scheme, you can open various layer stacks from various projects. And for instance, if you split the screen, you can easily compare them, edit, and verify them. The other cool thing is you can visualize your stack up in 2D or 3D with different viewing options. You can see real layer height, full stack views, and so on. The other improvement aspects of this general layer stack improvement is the access to a wide selection of material library of all types of materials. And of course, in those cases when you need to add a specific material from your manufacturer, it can be easily added with this new button. Within the new Layer Stack Manager, you have access to a new advanced impedance calculator. It's accessed from here at the bottom tabs. Once here, impedance profiles can be easily added. Let's add a 50 ohm profile. As you can see, this automatically includes all your layer stack in this impedance profile with automatic reference assignments, as you see here from the drop menu. Layers can be omitted or included per your design needs. Here on the right are your impedance profile properties, where you can select whether this profile is for single, line, or differential. It's very intuitive and straightforward. You can either let the solver calculate your trace width by selecting the impedance, 50 ohms in this example, if and when this FX is highlighted. So as you change the impedance, the trace width is automatically updated, or vice versa. You can enter the trace width and see what the impedance would be. You see here all the parameters that are included to calculate the impedance accurately. And that's where also the material library plays a role with accurate material properties. Let's add another profile, but this time for a differential pair. And say you want to route your USB as a diff pair with a 90 ohm impedance. So select differential and change the target impedance to 90 ohms. And here you might notice there is an additional calculate parameter, which is the gap between the differential pairs. And once these impedances profiles are ready and saved, they can be referenced in your design rules. So let's go to the rules and go to the width rule for single traces. And here, as you can see, I can check if I want to use this impedance profile for a net class, for example, and the same goes for differential pairs. Let's go back to our layer stack and access via types. In Altium Designer 19, we're making support of micro vias as well as blind, buried, and skip vias easy, giving designers the capability to design the most complex stack up scopes with ease. And similar to the impedance profiles, you can add as many vias profiles as your design needs. Once you save your via profiles, then they become accessible during interactive routing. And so let's go to interactive routing. So let's go to route a trace. And as you start routing, a simple control plus L as in Larry, you get a quick drop-down menu to select the layer you want to switch to. And once you do so, you can see here on the right an image depicting the via stack profile that will be placed. If you hit the number 6, for example, on your keyboard, you can cycle through them, or number 8 to see the list of possible via stacks. Once the via is placed, you can separate them by clicking Control and dragging them, as you can see here. And we can also see this clearly in 3D. Let's move to new part search. Altium Designer 19 new part search panel acts as a cockpit for you to narrow down your choices from the major parts providers. with the ability to search and filter using parametric information, such as frequency range, for example. So let's look for a crystal, for example, and as you can see, I can filter by frequency ranges, component tolerance, height, and much more. And as you narrow down your choices, you can easily compare two components from the search result to even further narrow your selection, as you can see here. And with the red text, meaning parameters that differ. Let's quickly take a look at component panel. And this is where you would be managing your components and libraries. Similar to the parts search, you can search and filter using parametric information to find components from your libraries. You can search using component categories as well as text phrases with the text and number to narrow down your choices. For example, let's enter 16 kilobytes, and that's the amount of RAM I'm looking for in a processor. And here are the narrowed down results that include all the components in the library having the same numeric value. Let's show some routing improvement. The first of which is component move retrace, which enables you to move any component as well as any relevant parts of routing. An example would be, as you can see here, some vias and some tracks. And that enables you to move them to new locations without having to worry about any rerouting, glossing, or cleanup. And although moving a component is generally done during the placement phase prior to routing, there are times when some components need to be moved post-routing phase. And another cool new feature, routing feature, is the follow mode, which enables you to perform contour routing and hugging, as it locks the current route to any adjacent contour, as you can see, trace, or curved outline. And this works well for those designs that have round or around curves areas, such as the flex section of a rigid flex design. And there are many other routing improvements, such as the unconditional automatic loop removal, as you can see, so you don't place a new self-intersecting trace within the net you're trying to route. And if we go to, for example, differential pairs, you can see that it always yields symmetrical differential pair paths entry and a nice zip up. And also push glossing. If I try to route this differential pair and push these routes here, you can see that the glossing is extended beyond just the adjacent traces, which yields much better push results. Let's move to Draftsman. Documenting your design has got much easier now with Draftsman. And on top of performance improvements, we also added some new very useful tools to further better document your project. Now you'll have the ability to turn on and off layers, like in your PCB editor, giving you options to display more needed information on a drawing. An example would be mechanical layer, wires, cables, etc. And this works with assembly and fab views. And now you can have a board region view, which is useful for PCBs with variable stacks, such as rigid-flex, which will automatically place corresponding PCB name when callouts are added to the region. You can also now have a new realistic view, which captures the last 3D view on your PCB editor. Again, more useful tools to communicate your exact design intent. And now let's go briefly over the multiboard. Altium Designer 19 comes with an improved multiboard functionalities with a new 3D kernel that enables fast geometric modeling. It supports rigid flex design, as you can see in this example, and now we have a much better approach to mating boards or imported 3D models by simply relying on a single point for each part. So let's mate this rigid flex cable with this board. Let's enter the mating mode and select one side of this connector where the cable will go, and then select the mating side to that connector. And that's it. Now they can be locked. You can also export your multi-board design to a step or parasolid file so you can share them with other stakeholders. Printed electronics support. So if we go back to our layer stack, and click on Features here, you can see an option called Printed Electronics. Selecting this option changes the layer stack to a printed electronic stack with this layerless concept, if you will. Let's switch an existing one. Here you can see there is no solder mask, for example, and you can see that layer number 1 is actually the one at the bottom. That is because printed electronics are ink printed, and therefore layer 1 is the first layer in the printing order. If we look at this design, we have these patches between all crossovers, and that's what distinguishes a printed electronic layer stack, because traces that overlap constitute a short, and therefore they need to be isolated. A typical PCB don't need to do this because the layers are already separated and isolated. And that's the other thing Altium Designer 19 does. It knows that this is a printed electronic design and will flag traces that overlap as shorts within your design rules. And the way to mitigate this, Altium Designer 19 with this new printed electronic tool that we pull from here can automate the generation of these isolating patches throughout the design. Something that would take a very long time manually and can be prone to errors. Of course, there will be something that they will forget, or a patch that they will forget. Well, that was a quick tour of Altium Designer 19 highlighting some of its new functionalities and capabilities. Thank you for watching.